Section 7.1.13. The graph to the right is the uniform probability density function for a friend who is X minutes late. So down here on the horizontal axis, we have time in minutes, which is the X minutes. And then we can see here that the 1/30 represents the width. Now for part A, we want to find the probability that the friend is between 10 and 15 minutes late. Now the area under the graph of a density function over an interval represents the probability of observing a value of the random variable in that interval. The probability that the friend is more than 10 minutes late but less than 15 minutes late is the area under the uniform density function between 10 minutes and 15 minutes. So if we look at this and we want to draw, that means we're going to have a rectangle. Okay, and then within this rectangle, we can see that the width is going to be 1/30, which is what we get here. And then the length is the difference between 10 and 15. So if this is 15, then 15 minus 10 is going to give you 5. So from the graph in the previous step, we can see that the length of the time interval is going to be 5 minutes. And now what we're going to do is find the area of the shaded region, and then rounding it to 3 decimal places. So the area is the product of the interval length and the density. So the probability is equal to the area, which is equal to the length times the width. Well, 5 times 1/30 is equal to 0.167. So therefore, the probability that the friend is between 10 and 15 minutes is going to be 0.167, or we can write this as a percent, which would be 16.7%. Moving the decimal place twice to the right. In part B, it's saying that it is 10 a.m. There is a 40% probability that the friend will arrive within how many minutes. So what we're looking for is we're looking for the length. So to determine the number of minutes that will result in this probability, we need to calculate the width of the interval within a rectangle so that the area of the rectangle is 0.4. Well, here we know that this represents 40%, what's shaded. Or if we write that as a decimal, that is 0.4. So we know that the area is 0.4. We know that the width is 1/30. And we're looking for x subscript 0, which is the time. So now we're going to find the length of the interval. The area is the product of the length of the interval, x subscript 0, and the density. So again, the area of that is area is equal to length times the width. So we know that the area is 0.4. We know that the length is x subscript 0 because that's what we're looking for. And we know that the width is 1/30. Now we want to be able to isolate and solve x for the x subscript 0. So we can multiply both sides by 30. And so on the right side, we end up getting x subscript 0. And then 30 times 0.4 gives us 12. So therefore, there is a 40% probability that the friend will arrive within 12 minutes. So that means that x subscript 0 is going to equal 12 minutes.